So, greetings everyone. Today we will learn about t-test. This is the third video in the series, and this might be the starting of actual statistics in the series. So, what is t-test? For that, I would like to show you some site, article site that tries to sum up what t-test is. So, let us just go to that site. So, here's the site. Uh, so here it is said that t-test is a statistical test used to determine whether a numerical data samples differ significantly from population or whether a group of two samples. So what it is a more simple test that checks whether the mean of two groups from same population differs a lot or not. So the purpose of it is to signify the difference between two data set or okay, so that's mostly it. It also lets us know that the difference could have been happened by chance also, due to outliers or something like that. So that is the type of t-test. Mainly there are three: an independent test that compares two different groups of same population. Then there is a paired t-test. Over here, the data is same, but it is one data is outdated, another one is not. Simply say. And then we have a one sample t-test in which we compare the population with sample. Uh, then we all are aware of statistical hypothesis, mean hypothesis, null hypothesis. Then there is the alternate hypothesis that we are trying to avoid most of the cases. It depends actually. So that's it on the t-test. Now let's fire up Jamovi to do something to do it practically. For first we will do the uh, with independent samples. So for that, let us just we can open the bugs. So over here we have the gender that will define our two groups. One is female, other one will be male. So let's just open up the independent. And the all the values that all these four values will be our dependent variables, and the grouping variable would be gender. So here we go. We can see the gender of female is not equal, the mean of female is not equal to mean of male. Sorry for that. And what we are trying to see here is, let me just see some descriptives. So we can see clearly that the mean of woman is higher than the man. So, but we don't know which group is which. So, which type of pattern, right? Okay. So, what LBLF actually mean is the L is for low, H is for high, D is for disgusting, and F is for frightening. So these are four categories in which uh, the people are categorized, whether uh, they are lonely, frightened, or disgusting, disgust towards bugs or not. So this is the independent sample t-test in which we take the whole population, the two samples from the whole population actually, two groups, not samples actually, and we can also see the homogeneity and normality test here. So these are two required tests that must be performed before doing the t-test to ensure that t-test gives the accurate result. So here is the normality test, and here's the homogeneity test. So if we come to the site, we can see here, where it is. I think it is not here. So it's not written here, but If uh, checking of these two must be checked because we don't want to have much deviation in our data, so it won't differ a lot. That's why these two needs to be checked. So that was about the independent t-test. Okay, so now we will perform the paired sample t-test. So let's go to t-test and click on the paired samples. So what we'll do now is that we will pair the values. So LDLF will be paired with, we can do again with LDLF, but that would give us anything. So let's do LDLF with LDHF, then SDLF and HDHF. And now we can check whether the hypothesis we are making over here will be not equal to. So this will come out to be true if we put it that way. So here it says the both mean does not equal to zero, are not equal. So here that is over here what we're trying is doing is what we're doing is the LDLF and LDHF are treated as the same values but at a different point of time. That's it over here. Now to the last one, that is the one sample t-test. For that, we can use the big five. So it's data about personality traits. So it's let's select everything actually over here. So because nothing is useless here. So over here we will check if the value is equal to something or not. Let me just get the descriptive first. So we would like to set it the mean, that would be 321, 3.8, 3.21, and it wouldn't do actually anything. So let's just remove this, this, and this. Well, we are having issues because there is some normality. There is difference. So this is about what the one what one sample t test. And now we would like to cover regression. And after that, I would be doing ANOVA. Thank you and see you in the next video.